Okay, so we're going to start at 6.3 exponential functions. Up until this point, what type of function have we been analyzing? Linear. Very good. And linear functions graphically look like what?
Straight line.
A straight line. Algebraically, what's the formula?
Y equals mx plus b.
Ooh, as a bonus, what's the standard form of linear?
A plus b.
A what?
Ax
AX.
plus by equals c.
Wow, nice. Okay, so you know it looks like a straight line. We're going to start exponential functions. And there are so many applications for exponential functions. I actually have a really great activity for you. Exponential functions are not a straight line, and it's not a quadratic, which we're going to get to. It looks something like this. So one of my favorite projects for this, or problems, there's one that I do that's called rumors, but it's based off another one called germs, which is perfect for this time of year. So just listening to my story, you can see me visually. If Mrs. Stewart is sick and she shakes hands with 3 people and she gets those 3 people sick, and then these 3 people each shake hands with 3 other people, and then each of those people shake hands with 3 people. What that means is it is growing exponentially. It's growing at a very, very fast rate. Do you see that with the germs? In linear equations, it was constant. Linear equations, you made, let's say, $10 per hour. So 2 hours is $20, 3 hours was $30. Exponentially grows at an extremely fast rate. There's also called, that's the growth. The other part of it is called decay. So when something decays, like a body, when it decays, it breaks down at an exponential rate very quickly. Alright, so let's look at these tables and see if we can identify if it's a linear or an exponential function. Now remember, a linear function, what is constant there? The rate of change. The slope, the rate of change, perfect. An exponential function, like I talked about, it's not constant. It increases at a rapid rate. So let's look at the first one. The change of y, which is 2, over the change of x, which is 1. Oh look, each of these changes was always 2 over 1, 2 over 1, 2 over 1. So is this a linear or an exponential function? Linear. Now look at this. Instead of adding, which is also linear, it goes from 4 to 8. If I were to add that, that would be plus 4. This would be plus 8. This would be plus 16. So I know it's not adding, and it's not a constant adding, so I know it's not linear. So let's look at multiplication. If I multiply this by 2, it becomes 8. If I multiply this by 2, it becomes 16. If I multiply it by 2, it's 32. So the rate is constant. However, instead of addition, like it is for linear, it's multiplication. And if it's multiplied by a constant rate, then the function is exponential. Alright, so you know that linear equations, y equals mx plus b, is the golden equation. This is the golden equation for exponential functions, where x is going to be greater than 1, a cannot equal 0. So first we're going to evaluate it. I know this is all brand new and it's just a matter of getting practice, and we'll have a whole lot of practice on it. So we have to do 3 different problems. We have to do this problem using -2 as x, then 0 as x, and then a half as x. So let's do -2. 2 times 9 to the -2. Oh, a -2. What is that telling me? Move me. So who is it moving? Only the 9 to the denominator. So it's now 2 over 9 squared, which becomes 2 over 81. Very good. Here's why you need to know sections 1 and 2. You need to make sure you're solid in those. Now let's plug it in for 0. 2, I'll put it here, times 9 to the 0. Oh! 9 to the 0 becomes 1. And 2 times 1 is 2. There's my second answer. Third answer. 2 times 9 to the 1/2. Oh! A rational exponent. That is the same thing as 2 times the square root of 9. We don't have to put a 2 there, remember, because it's already a 2. 2 times 3, which is 6. So, remember what the graph looked like. Let's just do a really quick sketch of this. If x is -2, right here, y is 2 over 81, which is a very, 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 very small fraction. If x is 0, y is 2. If x is a half, which is like right here, y is 2, 3, 4, 5, 6. So if you look at this graph, take a look. See how quickly it's growing? It's a curve. Now it's not going to hit the x-axis. I drew that a little bit wrong. It's not going to hit it, but if you can see it, and if I keep going, let's say I put it to, let's do another one. Let's say it's 2, 9 to the 2nd power. Well, 9 times 9 is, right? 2 times 81 is, wow, so just, that's at a half already. So this is at 2, so 2, and goes all the way up here at 162. So you see how quickly that grows? All right.